Three, two, one. Okay, this is our presentation for the Nintendo Labo hardware that we made. Step one, identifying and understanding. We need to improve long and short-term preservation because the original kits are no longer manufactured, and they're also made of cardboard, which means they don't exactly hold up for long. It's also very expensive to replace a full kit, and some of them cost $120, $180, which isn't exactly great. And there's the current solutions. There aren't a ton. There are some guides in the games for repairs, and there's the option of buying a full replacement, which I've already gone over. You can rebuy kits on the Japanese website, but also that needs a laser cutter. Not everyone has that. Or you can buy the individual sheets and accessory replacements that cost a lot more. There's a research. We research material properties of cardboard, inputs used in the Labo, properties of the materials that we proposed, which you'll see coming up. Ideating. Initial ideas. Here's all the materials that we proposed. We proposed PLA, TPU, ABS, laser cutting, wood, carpentry, and a metal frame. The PLA is rigid, it's cheap, easy. TPU is flexible, well, a little more expensive, but it's very durable. ABS is hard to use, expensive, rigid, but also one of the more common 3D printing materials. Laser cutting wood is thinner, but it's also the most similar to what we had initially. The carpentry is thicker, heavier things, but it's also very effective. Therefore, that metal frame is the most durable, but also really weird and can tend to mess with things. There's a decision matrix. Here's a decision matrix. Decision. We use PLA for our general use. TPU is useful for buttons and pins. Laser cutting for larger pieces of frame that aren't feasibly these things that we can make with 3D printing. Carpentry is parts with pressure applied to them like with pedals. Testing and refining. Design process. Preparing things. You took the original PDF, turned them into DXF, placed those over, turned them into Fusion files, extruded everything to the right length, and then we moved on to modifying, where we would fold them into the appropriate shape. Add hinges is to replicate folds in anywhere it changes. Add levers, anything like that that we needed, and then we produce it, which is the 3D printing, laser cutting, carpentry, anything that we need to actually put it together. Initial testing, bunch of stuff. We tested tolerances on the 3D printer. We tested how close to the cardboard and other things interface with that. We tested the actual materials with TPU PLA. We tested their weight with buttons. We tested 2D springs to figure out what's best for rebounding. And we also tested infrared compatibility by putting infrared stickers on the different materials and testing that. Here's all of our images. We did the tests for test tolerance, throughout springs, all that. You get the idea. In terms of results, I can handle around 0.5 millimeters. Just without using layers on the printer. Cardboard's 1.5 millimeters thick, but a lot of it relies on compressibility of cardboard, and because of that, you really need to actually optimize for that and compensate by making your pieces a little bit thinner or using TPU for that. Best combination of lever and base is a TPU lever on a PLA base. This allows a lot of flexibility, but also the rigidity necessary. Weight of parts isn't a huge problem, but if you really want to maintain that sort of thing, you can just use low-end fill-on PLA. As materials available, white and brown PLA are the two best because they're matte and won't reflect too much. The IR, TPU, and the green one also work all right, but they are shinier, and that's not great. Here's all our CAD. You can see there's a pedal, RC car, all bunch of stuff. You get the idea. There's individual parts, full parts, assemblies, final designs. Here's some of our prints. There's the RC car, the 3D print inserted onto the cardboard already existing. There's a holder that we also use to test our dimensions and how close things are to the actual controller. And we have the stand for one of the many things in the Labo. Here's more. We got our CAD. We have a different part of that cardboard one. We have one with IR. We have some ripcords, that sort of thing. Impact. The original cost of things is a little pricey now that things are aftermarket. Our thing is a little cheaper. Because it's super expensive. This one is going to actually last a while as well because it's not made of cardboard. Market potential. Nothing does this before because it's a single-use product that's only been made once for one thing, so it's not the most common thing. It could re-spark interest in this sort of thing, which would be great and really cool because it's a solid game. But it's also not super original because it is still making something from something already extant. Social value, preservation of art form, and a unique cross between them being video games and papercraft. It fixes a lot of the problems with longevity, allowing things to be better preserved, and most of the plastics are recyclable, bar TPU, but the ABS used in the original also isn't recyclable, so it kind of evens out, honestly. And this also preserves the game series, which really isn't designed to be preserved all too well once it's aftermarket. Here's a lot of sources. You get the idea. Cool.